Welcome to the video on the DMAIC process. This is for industrial statistics at Virginia Commonwealth University, but anybody can use it. Okay, so we've been talking about Sigma, and Six Sigma uses is a paradigm that is used for quality improvement and as well as quality control and setting up confidence limits. But in general, Six Sigma is a paradigm that's used in general for improving your process quality. So what we're going to do is talk about the DMAIC process. It's a 5-step problem-solving approach. The first step is define, the second step is measure, the third step is analyze, the fourth step is improve, the fifth step is control. Now, DMAIC is not exclusive to Six Sigma and can be used as a general paradigm for any problem solving in any business situation. All right, so DMAIC. Okay, before a project is taken on, a team must be formed and should include what's called a project champion, a person who wants to see this project completed and is willing to be part of the project from beginning to end. Okay, so they're committed to it and they want to make sure that it's promoted among their peers. It should have people that work directly on the project. So who will be working on the project? They should be part of the team. You should have stakeholders like end users or who the next person is, the customer or anything like that. They should be on the team as well. And you should have master black belts or black belts not working directly on the project. So these would be people that you could refer against. Okay, so what they're going to do is write a 2 to 3 page project charter that is going to outline the problem, and we'll see what that does here in just a second. The goal here is to have this. All right, so once you complete one of these steps, or 5 steps, you're going to pass through what's called a toll gate, or that's what it's been called. And at each toll gate, the following should be evaluated. Number 1, can the project be completed on time? At every one of these states, you can say, can we finish this thing? What tools are being used? Do we have the correct tools? What are the obstacles that are completion of the next step? So suppose we're in the analyze and we want to go to the improve step. Do we have any obstacles that we need to overcome before we do that? And if we do have them, how do we overcome them? And the project charter, does it need to be updated? Maybe we learned something along the way in one of these steps. We might need to update the project charter so that it has a different scope than what we originally started with. Now, the toll gate should be completed as soon as possible after each step of this process is completed. That way it keeps things on time. Okay, so step 1 is define. Okay, so the first step is to identify a project opportunity. Verify that this has a potential for a legitimate breakthrough. So it's going to be worth the time that you're going to put into it. Verify that it's important to the customers at the other end, and verify that it is important to the business that you're currently in. Because some things might not be important to customers at all, but might be very important to the business that you're in. Okay, but these are the key items that you should be trying to define when you start this. Okay, so when you do this, the project champion should initiate the creation of a project charter, 2 to 3 pages. Might even have a template that they start with. But it needs to have a description of the project. Okay, so describe what you're trying to improve and how you're going to, in general, improve it. You should also have a scope of the project. How big of a project is this? Is it something that involves many departments, or is it something small, something that's simple? You should have start and anticipated completion dates. And you could even put the completion dates for each of these steps so that you can see whether or not you're on time. Okay, whether or not you are fulfilling this project charter in a reasonable time frame. Okay, you would want to put any critical to quality characteristics that might be impacted by the project. Even though you're not trying to fix, let's say, some problem that exists in the process, but, you know, maybe when you adjust this one item, it throws another one of these CTQs or CQTs out. Okay, so just be careful Are they going to impact other ones? Then you're going to have some primary and secondary metrics of success. How do we know whether we're working correctly? One metric of success is, are we on time? Another metric of success is we're able to do this cheaply. Okay, we want to know how these metrics align with corporate goals. So do these, maybe it's we're trying to make the process safer or other things. These are metrics of success. And then we want to list out any potential benefits to the customer, because they're the ones ultimately who are going to benefit from this. We want to list out any milestones that we should make, and these are often these toll gates. It should also list the project members and their roles. And it's kind of noted that if a project charter takes more than 2 to 4 days to complete, then it's probably too big in scope for this process, because there's probably a lot more moving parts than you would expect. All right, so the next thing you would do is you would try to make a diagram that's called supplier, input, process, output, customers. Okay, this is the SIPOC diagram, and it's a map of the process. And there's a picture of one of these on figure 2.3 in the text. So here the suppliers are the people who provide information or materials that are worked on in the process. Input is the information or material provided. Process is the set of steps to complete the work. The output is the product, service, or information produced, and the customer can be internal or external who receives this product or information. Okay, and you want to list all these people out so that you can see where everything's coming from and where everything's going to. Okay, at the end of the define step, you're going to have a toll gate review, and you should be able to answer these when you approach this toll gate. Does the problem statement focus on symptoms or causes? Okay, you want to say, oh, this thing is this part that it makes, like phone case, is always loose. Well, that's a symptom. What's causing it to be loose? Okay, are all the key stakeholders involved? Did you go through and ask all of your customers, or you just use the one that's really picky? Okay, is there evidence that there is a value opportunity in the project? So you have to say, look, if we do this, there's a chance that we can increase the quality as well as improve the value here. Maybe even got some costs. Is the scope of the project appropriate to meet the goal? Okay, can we meet the goals of the project within a reasonable scope? Okay, have you created the SIPOC diagram so that we can see where everything's coming from and where everything's going? Okay, if there's barriers or obstacles to this project, have we identified them, or at least the ones we know of? And does the action plan seem reasonable with the correct timeline? Like, we put milestones out there. Can we actually meet those, or is this going to be difficult to do? Okay, then once we've completed this toll gate, we would go to the next step, which is measure. Okay, and what we want to do is get a sense of what the current state of the process is. So we're going to look at some measures of quality, measures of cost, measures of throughput. These will perform what are called KPIVs or KPOVs, key process input variables, key process output variables. And each measure that you're going to measure here should be completely defined, not just say, I'm going to pay attention to, for example, the width of the part. What do you mean the width of the part? How are you going to measure that width? And what you're going to measure it with, for example. Okay, and here, deciding what to measure is important, because this is where you're actually going to start making those metrics that decide whether or not you are being successful. Okay, so one might be process time. How long does it take for this process to run? Okay, and then if we have multiple items during this process, do I have to wait between items? For example, maybe when I get the item from the previous process, and maybe that was a welding process, and they're hot. I can't go and do my process until the parts themselves cool down a bit. There could be some waiting time, and that waiting time is time that is basically not being productive, because you're waiting for something to happen versus actually doing something. Okay, The other thing when we measure something, does it measure the key process variables? Okay, you got to make sure that if you have key process variables that you're actually trying to measure them. You should also measure both value-added and non-value-added aspects of the process. Okay, how should you how to decide on things to measure? Well, you can look at important items like historical data. So, for example, I've been paying attention to this process, and it seems as though it runs out of control, out of quality control, or it sits idle a lot, or which costs money, or there could be lots of information that just already exists, and that can tell you, oh, wait, we should really pay attention to that. Another way to look at what is important is do a quick observational study. Watch the actual process as it goes through and say, oh, wait, are there things here that we should be measuring to make sure a quality product comes out that matches up with our key process variables? And the other thing you need to make sure is that you ensure you have a large enough sample size to understand the process. If you just watch the process one time, maybe that's not good enough. Maybe you need to watch it over and over again to see exactly what happens and what sorts of variations in the process happen, because not everything is smooth as you would like it to be. Okay. Now the next step is asking, can we actually measure these variables? Okay. So we have reliable measuring equipment to measure it. Like if, for example, we're measuring happiness. Well, measuring happiness is really difficult and it's really unreliable. Okay. Because people can be happy one moment and sad the next moment. It's not as easy as you would think. But do we have the reliable measuring equipment? Okay, can we reproduce the measurements consistently? Okay, so this would be like gauge R&R, reproducibility, reliability and reproducibility. So if I measure the same item multiple times, do I get the same number? So it's going to be the same item. I'm going to measure it multiple times on the same dimension. I should get something that's really close to each other every single time, if not exactly the same. Okay, and are we measuring at the correct resolution? Okay, I know this doesn't really make sense, but, if you're using a tape measure, you might not be having a fine enough measuring equipment to measure something that you're interested in it being in the 10,000th of an inch. That's going to be hard to pick up on a tape measure. Okay, now when we do these measurements, we're going to take all of these measurements and then we're going to look at this as a process baseline performance. This is what we're going to compare to later to see whether or not we were successful. So we need to know, what is the process doing now? That way, when we ultimately put the improvements in place, we can say, yeah, it worked, because we have a measure of how it was before we did anything to the process. Okay. You should also, in this time frame, create summaries of the data collected. You could do histograms, run charts, meaning like what we're going to talk about with these control charts, scatter plots, Pareto charts, and we'll talk more about these later. But the idea is you want to have evidence, and this is where you're building evidence. You've collected some data here, you've measured some stuff, and now you want to see if that just works along with the goals ultimately. Okay. So when you decide all of these, so at the tollgate review, the following question should be answered. Is there a comprehensive process flow chart? Okay, I didn't really talk about that before, but do we know how things go from A to B? Okay, and that's one of the things. Is there a complete list of key performance, input variables and output variables, and how are they related to the critical to quality control variables? Are the measurement systems actually capable of being able to measure what you want reliably? Are all assumptions that you've made about the process listed? Okay, because if you've been making assumptions about the process and you can list them out, then you can check to see whether they're true or at least close to being true. How did you decide what to collect? So you might want to have some sort of narrative on, well, we were doing this and these variables seem important. Okay, the next one is how valid is your measuring system? And did you collect enough data? Okay, this is what people will ask. Do you collect enough data? Once we have this data, because we've measured it, we can go to analyze it. Okay, and we want to determine the cause and effect relationship in the process and understand different sources of variability. We want to separate sources of variability in what are called common causes. These are embedded in the process itself and can usually suggest how the process can be changed. And then there's what's called assignable causes. These are usually arise from external source, and it usually, when you look at them, usually suggest ways to eliminate the problem. Okay, so that's what you're looking for, okay? Because these are things that you don't really have control over, where the common causes you do have control over. All right, some tools to figure this out. So control charts. This helps to separate common cause from assignable causes of variation, because you can see how the process is varying on its own, and if something external happens, you can see, oh wait, this was from an assignable cause. Okay. Another thing that when you're doing these analysis, you might do some hypothesis testing. Determine if the process under different settings produces a significant change in the CTQs. This is kind of like, design of experiments. You want to see if I change stuff, does it really make a big change on the CTQs? You can use confidence interval estimation, because you're basically trying to determine how much variation are there in the inputs that we're dumping into this. So it's just an estimation thing. Regression analysis relates one source of variability to another source of variability. So we can see if they're related. Something that I really haven't mentioned before, which is discrete event simulation. So you would create a computer simulation of the process, and then you can interrogate it to see where the sources of variation are. Because if you have it in the computer, you can do a whole bunch of experiments with it really cheaply versus actually having to stop a process and do these things and hopefully set it back up correctly. Another thing you would want to do is look at the process and look for failure modes and effects analysis. And this is a technique for each source of variation that you've identified. You've identified sources of variation. Now what you want to do is be able to know, which one should I pay attention to? There's all these sources of variation. So this is the easiest way to do it. So you can think of A as being the likelihood something will go wrong. We're going to rank it on a scale from 1 to 10, with 1 meaning it's not likely that this thing will actually break, to almost certain this thing breaks every day, all the time, and it drives me nuts. Okay. B is the ability to detect a failure or a defect or error. Again, you're going to rank it on a scale of 1 to 10. So if it's really likely that you'll detect the problem, then it gets a low number. If it's really hard to detect, then that's more of a problem because you don't know that there's a problem. C is the severity of a failure, defect, or error. So again, ranked from 1 to 10. 1 is, if it breaks, there's a little impact, to 10, which is where there's an extreme impact, excluding extreme financial loss, injury, or loss of life. Okay, but to create this risk priority number, you would multiply A times B times C. Okay, and then sources that have the highest RPN are the focus for further process improvement or process redesign. So you've got all these sources of variability, you do this to it, and you go, wait, we really need to focus on this one over here because it helps you focus in on the ones that matter. All right, when you're going to get to the toll gate review for these, you should be able to answer the following. Okay, what opportunities are going to be chosen for further investigation and the improve step? Because, some things you might have analyzed and look, it doesn't really matter what we do. This doesn't really change it that much. Okay, what data analysis supports this investigation for this opportunity? And will it have an outcome on the CTQs or the output key performance output value variables? Okay, are there opportunities that are not going to be further evaluated? For example, we get here, we've measured, and we're like, yeah, really, there isn't as much variability as we thought. we're just not going to go further with that one. Then we would ask, is the project still on track with respect to timeline and anticipated outcomes? So at this point, you're really saying, have I done enough yet to really make these connections on between variables and whatnot? And also you would want to know, do we need additional resources at this time, or are we good? Because once you get to analyze, now you're going to improve something. You might need more resources to be able to actually do that. Okay, so the next step is what's called step 4, which is improve. The goal here is that we find opportunities in step 3 to redesign the process and or change the process. So we're going to try to improve the workflow, reduce bottlenecks. Flowcharts and value stream maps are handy here. So if you know what a flowchart is or a value stream map, this is a good way to know if there's bottlenecks. Another type of improvement is what's called mistake proofing the process so that it can only be done one way, the right way. Okay, there's lots of people who are trying to do this. Just think about it, you go and take a survey, and if it has a star by it, it means you have to fill out that item. They're trying to mistake proof it so they're sure that they collect the right information. In order to improve, you might do some design physical experiments on the actual process or a computer simulation to see if the various sources of variability actually impact the outcome. You could also use design experiments to find optimal factor settings so that it's the best part it could possibly be by your criteria. Usually whenever you do this, you're going to have a pilot test solution. Should have been evaluated to confirm that the proposed solution meets the goals and actually produces an improvement in the process. Okay, so you're going to do a pilot test and say, okay, well, if we change the process this way, does it actually work? And then the last step is to iterate on these to refine the changes to continue improvement. So keep going back over it until you've got it good. Okay. At the toll gate review, the following questions should be able to be answered. How is the problem solution obtained and documented? Okay. Do we have documentation on alternative solutions that were considered? Okay. Complete results of the pilot test included data displays, analysis, experiments, and simulation analysis. So we want to be able to look and see whether it worked. Are there plans to implement the test pilot products on a full scale, or is it just going to stay in one store in one corner? Okay. Do these agree with regulatory requirements? Right? You have regulatory bodies out there. You want to make sure whatever improvements that you make still meet the regulatory requirements. Okay, then you also want to look at an analysis of any risks of implementing the solution and what are your appropriate risk management plans. So you want to make sure that you have that documented. The last step is control. And this is where I've improved the process. I'm going to hand it off to the process owner along with what's called a process control plan and procedures to ensure that all the changes you've made will give them the gains or improve the product quality like they would like. Okay, so you would want to provide the process owner with before and after data on key process metrics to determine the improvement. You should be able to provide them with operating and training documents so that when new people come in, you can train them on it. Okay. Update process maps should be provided if you made serious changes. Maybe you need to make some changes on the process map. Okay, so you should also have here, before you start, this is before you start production, a plan for monitoring the process, including methods and metrics for auditing. Okay, so how are we going to do this? Well, this is how we're going to do it, and every now and then we're going to audit ourselves to make sure we're doing it right. All right, and then also control charts are defined and provided so that the critical process metrics can be modified or monitored and be kept in control to ensure that there's high quality. Okay, and then at the toll gate review, you should be able to answer the following questions and show that the data illustrating the before and after results are in line with the product charter. So if we said we're going to do this, we actually do what we said. and we got some data to back up that we did what we said. Then we're going to have to evaluate if the process control plan is complete. Did we leave anything out? Do we need to add anything to this process control plan to make it work? Okay. Are there procedures to monitor the process, like control charts? Are they there? Are they ready? Are they already set up? Do I know what my upper and lower control limits are? Things like that. Another thing is, some people like to journal. Well, this is basically what it's asking for. Is there a summary of lessons learned from the process available? So maybe you didn't know certain things about the process. Yeah, the engineer knows how it works, but you might have learned some things like, hey, if I feed in the material too fast, this bad thing happens. That's not part of something the engineer would pay attention to necessarily. Okay, is there a list of opportunities that were not pursued? So there might be opportunities that you thought, oh, I could put that within the scope of this, but then you realized, no, if I do that, then I won't be able to really focus on my original opportunity. And then are there other opportunities that you learned about that you should pursue? Okay, as you're going through this, you're going to learn things. Okay. And then also have a list of opportunities to use the results of the project in other parts of the business. Okay, so is there some way that we can tie this into finance or something like that? So, all right. So the next thing I want you to do is read section 2.7 for examples. There's several of them there. They're pretty good. And they sort of reinforce these 5 steps. All right, so I'm going to stop here. It's 26 minutes in or 27 minutes in. So have a wonderful day, and I will see you in the next video.